Hey everybody, welcome to week 2. This is statics, Et221, and nice job on week 1. I am going to do a little lecture on week 2, or chapter 2 for week 2, and I'll probably do another one on Wednesday. So before I get started, I want to talk a little bit about Blackboard and kind of the pace and organization of the class, and a couple things about your first homework sets, which overall were really good. Most of you did watch the homework format, I think, and you followed it. So excellent job. All right, so let's bust into Blackboard a little bit. Go to the home page. So this is how I'm going to set it up, where you kind of just see current information. Like this is week 2. I know this says empty until noon, but that's because I'm shooting this video right now for you. And as soon as I get it done, that'll change, right? So if we're in week 2, and in the calendar, I actually did label the, sorry about all those extra calendars. I did label the weeks so we can see we're in week 2. And I do fill in the homework in this area. We're going to have a quiz here. So yeah, the calendar should give you some flow. It does say there's a lecture on chapter 2 here. But that's how you can kind of keep track of what week we're in. And it'll be normally the only week on the home page. So here's the deal. Past weeks go into past materials. In past materials are solutions. So if you need to look at a solution on a homework set, you got to go find the homework set. So past materials, week 1, was it Monday? Was it Wednesday? Was it Friday? So you got to keep this stuff straight. I know there's some organization required there. But like for instance, Monday, there was a lot on Monday. A lot. We did a lot of stuff, right? You did a lot of stuff. You had right triangles, you had non-right triangles. There was a homework format video, which I'm going to look at in a second. There's like my welcome one. Then I actually put up an image of the book because some of you didn't have the book, right? And then I will go back after the due dates and put in the solutions from the solution book, which is not always very informative, right? So sometimes upon your request, I will make a solution video, which that's what this one is, solution video, available. It's going to only be available after the due date. Sometimes, you know, it'll be a couple days after the due date. Excuse me, that was a coffee slurp. Anyway, so that's the organization of where to go get solutions and responses to the homework. Because, right, you're doing homework. The only value to that homework is A, if you understand it, and B, if you get feedback. So I am giving you feedback as best I can. Primary feedback will come with your grade on the homework set. So I want to show you that. In the My Grades area. Now, due to FERPA, I can't show you people's grades, but this is actually my grade. I grade myself, just so you have an example, right? So you can see here that I got 10 out of 10 on my welcome and intro video. I got 30 out of 30 on this assignment. I got 25 out of 30 on this assignment, and there's a comment. If you click on that, it will give you some information about your homework problem. This one says the precision is wrong. Only 2 places, please. So I'm going to talk about that in a second. If you don't understand the comment, it's your job to email me and find out more. If you see 20 out of 20 and then there's a comment, that's usually me saying, great job. Okay, so you can look at those or not look at those. If it looks like this, that just means it's not been graded yet. I still have to do grading or you still have to submit. Okay, and then there will always be a grade to date running with your current grade to date. The total thing I'll get rid of because we just don't need that. That's just total points out of possible points, and that's what this is giving you. So this does it weighted, though, like it's supposed to be based on the syllabus. All right, so that's how you get feedback on your scores. Please look at those comments. That's super important. All right. Let's go back to, I think that's everything in here. Calendar, my grades, homepage, and how that flows. All right. I guess I can click into week 2 and see what's inside there. Yeah, there's nothing in there yet. So there'll be a video, there'll be homework assignments, and sometimes I put other information in there. All right, back to me. Okay, so let's talk about chapter 1 just briefly, because I want to talk about 2 things, the homework format and the precision. So let's just do the homework format real quick, which means I'm going to go back and actually use that video a little bit and fast forward to the part that I want to show you. Whoops, sorry, past materials. Week 1, I bet it was on Monday, and homework format video, and skip to the end.
A mistake that we don't want to make.
Pause. All right, so this is a basic homework format setup that I want to see. Your name, the homework set, a date would be great, a problem statement, please. What you're trying to do does not have to be the problem word for word, but just a statement of what you're trying to do. A graphic, if you're going to use a graphic and you can't draw straight lines, then please use a triangle to make some straight graphics, some clean graphics. If you have any assumptions, note them. Like, my assumption is this is a right triangle because it has this little 90-degree thing, right? Something like that. Anything, any assumption you make, note it. That'll help me get into your mind as I'm grading it. Then obviously the work, the formula's filled in, please include the units. And then a solution, but we want the solution to be accurate to 2 places. So this solution is accurate to, I don't know, 10 places. There's no way from these numbers that we can get this kind of accuracy. So we're going to assume that all numbers come to us from the book with at least 2 decimal places, okay? That's just a blanket assumption. That means our solution can have 2 decimal places, and that's it, no more than that, okay? So this, I think if we continue on, whoa, not sure why that happened. You can see that I start to work out my final solution, which then I double underline and point to it with an arrow or highlight it or draw flowers around it. Whatever you want to do, okay? But something. Round it to the nearest 2 places. This could be slightly different than how the book solution's given to you. So you need to stick to your solution. It's actually more accurate than the book solution and the one that I'm going to look for. So hopefully that makes sense. If not, then email me or reach out to me somehow and I can try to clarify. The basic system is we're gonna give all numbers from the book 2 decimal places, right? So as numbers come to you, any numbers that we get, we're going to just say they're accurate to 2 places. So that gives us some kind of accuracy to work with through the problem. All right, great job. At the end of each chapter, you'll see a chapter summary, and that's a great prep for the quiz of that week. Doesn't mean that we got through everything, but it's a good indicator of what we talked about. So statics and you know what it is, right triangles, some numerical accuracy. So this is how the book does it. They do it with significant figures, which is not real common in industry. What's more common is if you got a number, how accurate is that number, and then working with the accuracy of that number. Dimensional analysis, that is just putting your unit on the number and then taking care of the units as you work through the problem. And then in the end, kind of the metric system and the US system. All right, so let's talk about chapter 2 a little bit. Chapter 2 starts with forces. Let me see if I can find the beginning of Chapter 2. Yeah, so they call it principles of statics, right? Forces and the effects of forces. So we're going to start with just defining forces. The characteristics of a force, it's down here, and the units of a force, and then they go into types and occurrences of forces. And finally, they start to work, they do principle of transmissibility here, where, you know, when you start to combine forces, that's when we need transmissibility. But right now, I'm probably going to skip that for now until we need it. Types of forces, this really just is terminology. You can read through that. And then we finally get into the components of forces, which is really where I want to get to today. So let's talk about it. Let's talk about forces. Oh, whack. I'm going to use this as my chalkboard, and I'm going to actually leave you on the visible side and just work with pencil and paper for a bit, and then I can bring you back. All right. So let's just talk about forces. They are represented with an arrow or a vector. And there's specific parts to that thing, okay? So forces. The characteristics, they have essentially 4 characteristics. And they're all represented in this arrow. So this means something, this means something, this means something, and then the overall effect of the force means something. So when you draw forces, their length is the magnitude. So if it's a 10-pound force, its length represents 10 pounds. Okay? If you had a 20-pound force, I'd like to see that arrow be twice as long, approximately. You do not have to set up a scale. But it's nice if 20-pound forces are longer than 10-pound forces. Okay? You can actually solve some problems graphically if you just make a scale and draw them graphically. All right, so we have magnitude. That's one of them. Let's say that the second thing is the arrowhead. That is what's called the direction. Oh, excuse me, the sense. Because the sense could be here or it could be here, right? So the arrow is giving you the sense, or which way along the line of action the force is traveling. So the arrowhead is the sense, the magnitude. So then we have something called the direction. Now, the sense is the arrowhead, so the angular position, if I had a vector going off there at 10 pounds, then this angle, that is the direction. So it's very easy to confuse the sense and the direction. The sense is whether it's going this way or whether it's going, here I'll use red for the opposite way, right? So the sense could be here where the direction would be the same, 30 degrees, right? But the sense could be up 30 or down at 30. So the sense is the arrowhead, the direction is the angle. And then there is one thing left. What do we think it is? Here, I'll mark it. Got it? Point of application, where the vector is applied. Okay? 4 characteristics of a force. Very important. When you report a force back to me, we need to have all 4 characteristics. Now, you can read through about types of forces, and you can read through about units of forces. I think you probably know the basic unit of our force, which is what? A pound. I've already written it a couple times. So in the SI system, the basic unit is a Newton. So then, of course, the SI system has kilo and mega, right? So you can put a kilo in front of Newton and get kilonewton. The N is always capitalized because that's the name of a person who came up with this system, right? And then the multiplier or the prefix is always lowercase, unless it's mega, and then it's a large M. Anyway, you'll kind of catch on to that. We're going to work in both systems. All right, so let's just move this forward, because really what you're going to do, the other thing we should, before I move forward, the other thing I should clarify is our sign convention for forces. Sign being whether it's plus or whether it's minus for forces. This is going to change through the class, not for forces, but for other things, other effects that we talk about. But for forces, the sign of a force, whether it's plus or minus, is whether it is heading in the positive right direction or the negative left direction, or the positive up direction or the negative down direction. Okay? That's when they are plus or minus. If a force is off at an angle, right, then it doesn't have one sign. It could have two signs, right? Its X effect could be positive and its Y effect could be positive. Or if it went down here, then its Y effect would be negative and its plus X effect, right? So forces at an angle often don't get a sign, they get their angle. Forces that are horizontal and vertical could just get a plus or a minus. For example, this would be a plus 20 pounds. That's its sense. And this is completely appropriate. I know if you write this, that it is positive to the right perfectly. But this, 20 pounds, if you wrote this, I would need to know what this angle is. I'll call it theta. In other words, I'd need to know, hey, I have the force equal to 20 pounds, but notice there's no plus or minus, and maybe I would write at an angle of a plus 20 degrees, which means rotation is from the x-axis in the positive direction to position it. This symbol also gives me that plus 20, right? Because I see it's from horizontal up to it. I could write the symbol like this. But that would position it more like that. And this one would position it more like this. So when you have a force at an angle, you have to give me more information about its position. I have to know, is it in the lower right quadrant, the lower left quadrant? Whoever's looking at your work and either accepting that work or, going through that work, they have to have a position of that vector. So that's super important. All right, let's keep going and do some components. All right, so the basic component system is just saying, if you have a force, and I'm going to just stick with a very common force, which is up and to the right. And I'm going to say that force is at 40 degrees, and you'll see quite quickly why we are spending time. So I'm going to say this is my force, right? 10 pounds at 40 degrees. And what we need to know when we have forces at an angle is what the effects are in the x and what the effects are in the y. With that information, I can combine forces and learn more about a system. So first thing we have to do is be able to find those forces. Typically, you want a graphical representation of the force, and then you want to draw in the components. And as you can imagine, that essentially is giving us a right triangle, because our force in the x, Fx, and our force in the y, Fy, are the horizontal and vertical components of 10. Notice that these two add up to 10. When you add vectors together, you put them together tip to tail, and then you close the system to get the solution of adding those two vectors. So we need to typically draw it. We need to put in all the information we know about that triangle. And if these are rectangular, meaning vertical and horizontal, then we have made a 90-degree right triangle, and we should be able to solve for those two components. Very important that we can do this. So that's why we practice those triangles in chapter 1. So if I want to know Fy, I need to look at what I have. I know the hypotenuse, I know the angle, and I know that Fy is opposite of the 40 degrees. Whenever I hear opposite, I know that is sine. So I will use the sine function and fill it in best I can. Sine 40 equals opposite Fy over hypotenuse 10. Fy equals, I do algebra to clear this, which means the 10 comes across and multiplies by the sine 40. So I can just do that maneuver. £6.4278761 pounds. Is that my answer? No. My answer would be Fy equals, which way is it going? It's going up, so that's positive. A plus 6.43 pounds. And I often put a vectorial notation to remind me that I know that my y component is going up. Okay, so if the problem said find the components, this would be one of the solutions. Everything in it. I have the magnitude. I have the direction, vertically upward. I have the sense, that's that arrowhead and that plus. And the point of application, would be here at point A. Even though you draw your components out here, all of the applications are back here at point A. So if I was to draw A with just the components, it really would look like this. Right? Because the components are the same as the 10. They're equal to each other. So here we just have no 10 coming out of it. We have the x and y component. Here we have just the 10 coming out, and I sketched in x and y. All right, we still have to find x. X is adjacent to the 40, so that should trigger cosine. And I know it's adjacent over hypotenuse. So Fx would be I'm running an HP, so it's a little different than your TIs. 7.6604443 pounds. I need to round that. Fx equals 7.66 pounds. And is my x going positive or negative? It's going positive. I could put a plus, but I like to notate it with a little vector over there to remind me that this component is going positive to the right. Rectangular components. Whatever you're given a vector over here, put in your components, sketch them in for me, label them, and then put your angle in and go to work. You're building right triangles to create those components. All right. That should clearly be enough for you to get started on your homework for Monday. I think you only have one problem. It's got like part A, B, and C to it, so I made it worth 30 points for you. But it's just practice with components. Pretty much it. Wednesday, you'll do some more realistic problems, not just given a line and a vector. So look through those too. And I might produce one more video this week to support you on the end of this chapter. So look through the chapter, read through it, please, and then work the homework problems and let me know how it is going. All right. I will see you all on Wednesday.